The homework tonight is going to ask you to solve for unknown values in 3 special parallelograms. First, the rhombus we see here on the top left-hand corner. Secondly, the rectangle in the top right-hand corner. And finally, the square, which holds all the properties of both. The diagonals are marked in each of these diagrams, and the problems on your homework will mostly involve the diagram. So we'll start by discussing the special properties. All parallelograms share the properties that the diagonals bisect each other. So anytime we are given that one half of the diagonal is, let's say, 6, we know that the other half must be congruent. So for example, in this rhombus, those two halves would be 6 and the entire diagonal would be 12. So we can put marks on each of these diagrams showing that the diagonals must bisect each other. They must cut each other in half. This is something that is true for all parallelograms. But each figure has its own special set of properties. For example, we'll begin with the rhombus. The diagonals not only bisect each other, but they cross at a perfect 90-degree angle. And so if you're asked to solve for the angle of intersection of the diagonals in a rhombus, we know right away that angle measure is going to be 90 degrees. And since this is true for the rhombus, it'll also hold for the square. The rectangle, the diagonals certainly do not cross at a 90-degree angle as we see in this diagram, but we'll come back to the special properties of a rectangle later. Coming back to the rhombus, the only other property we really need to concern ourselves with is that the diagonal bisects the angles of the rhombus. So for example, if we were told that this angle right here was 30 degrees, we can conclude that the angle right next to it would also have to be 30 degrees because the diagonal cuts it directly in half. And because we know the diagonals bisect the angle and that the opposite angles are congruent, these two angles would also have to be 30 and 30. Once again, since this is true for the rhombus, this is also true for the square. And in a square, we know exactly what these two angles have to be because they have to add up to 90 degrees and be equal to each other, so they would both be 45. Coming back to the rectangle, the property we need to worry about here is that the diagonals are actually the exact same length. So if we were told that this section right here was 7, and we know that in a parallelogram the diagonals bisect each other, so the other half here would be 7, so the entire diagonal from the upper left to the lower right would be 14. But we know that the diagonals of a rectangle are congruent, so this diagonal here would also be 14, which means each half would also be 7. So in review, for the rhombus, we know that the diagonals bisect each other, and they bisect the angles, and they are perpendicular, meaning that they cross at a perfect 90-degree angle. All of these things are, of course, true for the square, because the square is a special kind of rhombus. For the rectangle, the diagonals do not cross at a 90-degree angle, but the diagonals are congruent to each other. And because the square is a special kind of rectangle, we know this is also true for the square, that this diagonal right here would be congruent to this diagonal right here.